Welcome back to PV Online. Today we're going to take a look at mirror calculations with two unknowns. And in order to be successful, to be honest with you, the signs are going to be the most important thing. So we're going to take a quick summary look at what types of images you get depending on where you place an object with the concave and convex mirror. Now I've got this first diagram here, and we have the object that is placed beyond C, and you can see that the image is inverted, it's real, and it's diminished. Every time you have a real image, DI is going to be positive. Every time. Every time it's inverted, DI is positive. Now, it doesn't have to be diminished, but these two are always going to have an image distance that's positive. Now, let's take a look at if we have an object at C. Now, when we have an object at C, you can see that the object and the image are at the same location. That means the magnification would be 1. They would have the same size. It's real, it's inverted, which means my image distance is going to be positive. It's going to have a positive value. Now the next one we take a look at is when the object is getting closer to the mirror, and now we're between C and F. And when we're between C and F, do you see how the image is getting larger? It's still real and inverted. And since it's real and inverted, DI is going to be positive. Now remember, if you place the object at the focal point, the rays will be parallel, meaning there won't be an image. You're just going to see a bright light. Next, we take a look at if we get an object real close to a concave mirror. This is what happens in a bathroom mirror. You look inside that mirror and you can see your image. You're upright and you're very large. So in this case, anytime it's a virtual image, DI is going to calculate to become a negative value. And that happens every time you have an upright image. Upright and virtual go together. And last but not least, we have convex mirror. And in a convex mirror, all of the images are like this, no matter where you place the object. Every single time it's going to be virtual and upright. And since it's virtual and upright, we know that DI is going to be negative. Notice that I cannot make an enlarged image with a convex mirror. I cannot make a real image with a convex mirror. The only kind of image we can make is virtual, upright, and diminished. So let's go ahead and take a look and do the math now. We have an upright image. The fact that we have an upright image tells me right away that DI is going to be negative. So it says it's twice the size of the object. So if I were to look at this, I know that the magnification then is 2. And so I know that the image distance divided by the object distance is simply going to equal that magnification, which is 2, which tells me DI is going to be twice the distance of DO. Now it says the focal length of my mirror. The focal length of my mirror is 20 centimeters. And the question is, find the object distance. So we know we've got this mirror equation, 1 over F equals 1 over DO plus 1 over DI. But right now we have a problem. I gave you the value of F, but you don't know DO, you don't know DI. We have two unknowns, and as soon as you have two unknowns, we have to have two equations. And that's where this guy comes into play. All right, so I have this mirror, and I'm getting an image that's twice the size. It's magnified. That means right off the bat, you need to know that this is a concave mirror. So this is a concave mirror, meaning that that focal length is going to be positive. So I have 1 over 20 equals 1 over object distance. But since this is an upright image, I know DI is going to be negative. I'm going to make this minus 1 over, and instead of putting DI in there, I'm going to put in 2 DO. Now this is where your math teachers would be very excited, because we're going to use the skill that you learned at some point in algebra, and that's going to be this common denominator. And in order to get a common denominator, I need to multiply this guy by 2 DO minus 1 over 2 DO. That equals 1 over 20. Only now can I subtract these two. And when I do, let's get ourselves a little bit more space. When I do, this is going to give me that 1 over 20 equals, so 2 minus 1 is 1, over 2 DO. Now I have to do a little bit of cross multiplying, so I'm going to bring the DO up here. So I'm going to have DO then equals 20 divided by 2, and that's going to give me 10 centimeters. So my focal length is 20 centimeters. My object distance is 10 centimeters. And so let's go back and look at this. This is essentially what we're doing. My focal length is 20, my object is 10. What kind of image do we get? We get a virtual, upright, and enlarged image. And what kind of image did we have here? Upright, meaning it's virtual, and enlarged. So we know right away we did this right. Just for the heck of it, let's do a couple more examples. Okay, so now we have an object is magnified by a factor of 4, which means it's enlarged when placed in front of a concave mirror. So the fact that it's a concave mirror tells me that my focal length is that positive or negative. And a concave mirror is a positive mirror, so it's positive 20 centimeters. And I'm told that the image is real. So since the image is real, what does that tell me about DI? And I know that DI is going to be positive. And our job is to find DO again. Right off the bat, I know I'm going to be using my mirror equation, but just like before, we have a problem, and that problem is that I have two unknowns, DO and DI. But the fact that I know that I have the magnification of 4, and all DI and DO is a ratio of the image distance to the object distance, I can now say that DI is simply 4 times DO. Now I have to pay attention to signs. Since it's a real image, that's going to make this a positive 4 DO. So let's do this. I'm going to put this 1 over 20 equals 1 over DO. This time is going to be plus 1 over 4 DO. I can't add those terms until they're common. And the way I do that is I'm going to make this 4 over 4 DO. That gives me 1 over 20 equals, now simply 4 plus 1, which is 5, divided by 4 DO. Do a little bit of cross multiplying, and when I do that, DO comes in the numerator. I have 5 times 20 divided by 4. I'm going to get an object distance of 25 centimeters. So let's just confirm it. So we've placed an object now between F and C, and I'm getting a magnified image. So I have this diagram right here. I have my object between F and C. What kind of image do I have? I have a real and enlarged image. All right, we did it right. Okay, let's take a look at our final example. And with our final example, now all of a sudden my image is smaller. It's diminished. So it's 1/3, so my magnification is 1/3. It's a smaller image when placed in front of a convex. A convex mirror is called a negative mirror, which means that the focal length then is going to be negative 12 centimeters. Now, what's the only kind of image that a convex mirror can produce? And they're always virtual, which tells me what about DI? DI is going to be negative. All right, so let's take a look at our equation. I've got my mirror equation, 1 over F equals 1 over DO plus 1 over DI. Okay, so now how are we going to do this? I personally would probably just make this 0.333. Make it a number instead of a fraction. Equals DI over DO. That means DI is going to be 0.333. I think I added a few 3's there, DO. But it's virtual, meaning that's going to be negative. So when I come over here, I have 1 over negative 12 equals 1 over DO. But it's a virtual image, making this negative 1 over 0.33 DO. So let's take a look at this. That's going to give me negative 1 over 12 equals 0.333 divided by 0.333 DO minus 1 over 0.333 DO. Now this actually is good because our object distance is I can't think of an exception when it's not going to be positive. And so since this is negative 1 over 12, when I take 0.33 minus 1, I'm going to get negative 0.667. And that's helpful because my negative signs then will cancel out. And we do a quick calculation. You can see that that's 2. So my object distance then is simply going to be 24 centimeters. You have some homework problems like this, and you're definitely going to have a test question. So make sure you have these mastered. All right, we'll see you next time.